Today, we're diving into the incredible story of Grace Hopper. She was a pioneer who did something that, well, everyone thought was just impossible. She figured out how to teach a machine to understand English. And by doing that, she literally changed our world forever.
All right, just take a look at this. On one side, you've got this wall of zeros and ones. It's basically gibberish to most of us, right? That's what early computers spoke. And on the other side, a simple English word, something we use every day. That huge gap, that chasm, was the single biggest problem in early computing. And whoever could build a bridge across that gap, well, they were going to unlock the future.
Okay, so this is what we're calling the binary barrier. Think about it. In the early days of computing, if you wanted to talk to a machine, you had no choice. You had to speak its language. And that language was, to put it mildly, super restrictive.
I mean, just try to imagine this for a second. You want to write a simple sentence, but for every single letter, you have to look up a long string of zeros and ones. That's exactly what early programming was like. It was incredibly slow, and get this, a single typo, just one wrong number, could completely wreck hours of work. So what did that mean? It meant only a tiny group of experts could even use these machines. You just couldn't build the future like that. No way.
But this huge, frustrating problem was about to run headfirst into someone who just didn't take impossible for an answer. And that, of course, brings us to the hero of our story, the one and only Grace Hopper.
So who was this amazing woman? Well, for starters, Grace Hopper was a brilliant American computer scientist. She was also a rear admiral in the United States Navy, which is just incredible. But the most important thing for us to know, for this story, is that she was a natural-born problem solver. She was the kind of person who just couldn't stand hearing, well, that's just how we've always done it.
And you know, there's this fantastic story about her that just perfectly sums up who she was, right from childhood. When she was just 7 years old, she apparently took apart every single alarm clock in her house, all 7 of them. Why? Because she just had to figure out how they worked. It wasn't enough for her to know that they rang on time. She needed to understand the mechanics, the how behind it all.
So it's no surprise that this love for how things work, for numbers and mechanics, led her straight to studying mathematics. And eventually, it led her to the Navy and to the enormous Mark-I computer. And when she saw this giant, complex machine, you know what she saw? She saw a much, much bigger version of one of those alarm clocks. And just like when she was a kid, she couldn't wait to pop the hood and see how it worked.
And that's where things get really interesting. Because as she's figuring out this machine, she has this flash of genius, a total breakthrough. She realized everyone was looking at the computer as just a giant calculator, but she saw something else entirely. She saw a library. A library? I know, that probably sounds a little weird, right? How on earth is a massive, clunky machine full of wires and circuits anything like a nice, quiet library full of books? It's a great question.
Well, here's her brilliant logic. She realized that inside the computer, information isn't just floating around randomly. It's stored in very specific memory locations, kind of like books on a shelf in a library, each with its own spot. And that's when the light bulb went off. She thought, what if we gave those memory locations English names, like call numbers for books? See, the computer wouldn't actually have to understand what a word like add means. Not at all. It would just need to be taught that when it sees that word, it needs to go find the specific binary code stored at that call number. It's a lookup system. It's genius.
And that right there, that was the fundamental idea behind what we now call a compiler. But as we all know, having a world-changing idea is one thing. Actually getting people to believe you and making it a reality, that's a whole different battle.
And boy, did she face a battle. Pretty much nobody believed her. Her colleagues were totally skeptical. They were like, Grace, computers are for numbers. They're just really fancy calculators. The idea that a machine could work with something as messy and abstract as English, it sounded like science fiction to them. So her idea, it was rejected, just flat out rejected.
For 3 years, think about that, 3 whole years. Her brilliant, world-changing idea just sat there, gathering dust on a shelf because nobody could see the vision.
But she didn't give up. And finally, in 1952, after all that waiting, she got her shot. A senior officer decided to take a chance on her crazy idea and gave her the go-ahead. And Grace, she did not waste that opportunity. She built her program, the A0 compiler, and it worked. It worked perfectly. In that moment, computing history was made.
And that amazing success was just the beginning. It opened the door for something even bigger. Grace went on to lead the team that created COBOL. It was a programming language that looked a lot more like English, built on her compiler idea. It made programming so much more accessible, especially for business, which is why she's often called the mother of COBOL.
Okay, so this all happened a long time ago. Why are we still talking about it? Why does it matter to you and me right now? Because what she built isn't just some dusty old thing in a history book. Her work is still a fundamental, living part of the world all around us.
Get ready for this, because this number is wild. Even today, a staggering 80% of all business transactions still rely on COBOL. That's right. Every time you use an ATM or a credit card, there's a very good chance Grace Hopper's legacy is in the background, quietly processing trillions of dollars across the globe. It's mind-boggling.
But her legacy is bigger than just code, you know? It's even woven into the words we use when we talk about tech. Here's a fun one. Have you ever actually wondered why we call a glitch in a computer a bug?
Well, you can thank Grace Hopper for that too. The story is, one day the computer she was working on just stopped working. So, being Grace, she opened up the machine to find the problem herself. And what did she find? A literal moth stuck in one of the machine's relays. So she carefully took it out, taped the poor thing into her logbook, and wrote next to it, "First actual bug found." And just like that, the term was born, and it stuck.
So, when you boil it all down, Grace Hopper built that first essential bridge between us and the machines, between human language and computer logic. It's a bridge that we all cross, probably hundreds of times a day. Every time we use our phones or laptops, she taught computers how to understand us. And now, as we're creating AI that can learn and create by itself, her legacy leaves us with one really big question to think about. What's the next great lesson we need to teach our machines?